Okay, so apparently there's been some confusion as to how these volume formulas work. The videos that I linked, maybe she kind of glosses over kind of what makes these formulas tick. And so I wanted to do a video that addresses all of the formulas, and we kind of just have this one general idea that drives all of the formulas for volume. So when we're talking about volume, whether we're talking about a rectangular prism, a cylinder, this is a triangular prism, or any of the other ones, what we're talking about is how much space it would take to fill up the whole prism or the whole object from top to bottom. Okay, so the underlying kind of theme of all of it is we want to take the area of whatever the shape of the base is, and we want to multiply that by the height of the object. So when we're looking at this rectangular prism, okay, it says it in the name, it's a rectangular prism, so that means it is a rectangle, but it's, being a prism means it's three-dimensional. So we would want to find the area of the base. So the base, in my vague attempt to draw a three-dimensional figure here, the base is a rectangle. Okay, so it looks like a diamond there, but in 3 dimensions it would be a rectangle. So we know that the formula for area of the base, so the formula is volume equals big B, that means area of the base, times height. But the formula specifically for this, we know that the area of the base of a rectangle, so we know that formula for area of a rectangle is length times width. So we would find the length times the width. Okay, so that gives us the area of the base. Then this dimension here is the height. Okay, so we're going to, the area of the base times the height. Well, the formula for area of a rectangle is length times width, and we multiply that by the height. So that's how we get the formula for a rectangular prism. Okay, so now let's look at this volume of a cylinder. Okay, well, what is the shape? Again, we're going to do big B times H. So area of the base times the height. Area of the base times the height. Well, what is the shape of the base of a cylinder? It's a circle, right? In order for it to be considered a cylinder, okay, three-dimensionally it looks kind of goofy, but that would be a circle. So our formula for area, a volume of a cylinder is going to take the area of the base. So V equals area of the base. So what's our formula for area of a circle? It's pi times radius squared. Side note, looking at your homeworks for area of a circle, some of you didn't multiply radius times radius. You did radius times 2, right? This is an exponent. So we're going to do the radius times the radius. So we would need to know this dimension. Okay, that's the radius. So we'll do radius squared times pi. And then we're going to multiply that again by the height. So we want to know what it's going to take to fill up this soda can. Okay, so the area of the base times the height. So pi r squared times height. Okay, we won't worry about this one. I'll give you this one. We don't have any problems with this, but you might see this somewhere down the road. Again, all volume formulas, area of the base times the height. So for this one, it's a triangular prism. We know that because the base is a triangle. Okay, so again, what's our formula for area of a triangle? We want to find the area of the base, which in this case is a triangle. So we would need to know the base and the height of the triangle. So we would need to know this dimension, and then we would need to know this dimension. So 1/2 little b times h of the triangle, and then times the height of the prism. So this formula is a little bit confusing. Don't worry about this one, but that's how that would work. So the takeaway from this is all volume formulas mean area of the base. Okay, so base. So this is a circle. This one's a rectangle. On some of the other ones, maybe the cone. When we're talking about cones and spheres, the difference with those is, let me erase this one, and I want to real quick, before we kill this video, if we had, let's say we have a cone. Okay, so cones are a little bit different. Okay, so the biggest difference here is that our height is not, it's not a prism. It doesn't go, the height doesn't go straight up. It slants inward. So that's why this formula is special. Somewhere somebody found out, and you can look up, how this formula works. But we're going to take, again, the area of the base, which is a circle. Okay, once again, we've got a circle. Okay, so we're going to take the area of the base times the height. Well, this one's different because the height is slanting inward. So this one actually needs to be multiplied by 1/3. And there's a specific reason why that happens. So we're not going to get into that in this video. But I am going to rewrite this formula. So we're going to be 1/3 times the area of the base. Well, we know that the area of the base is an area of a circle. So times pi times radius squared, and then that's going to be multiplied by the height. Now this is this is called the altitude height rather than the slant height, so we would not want the height being measured from the outside. We would want it being measured from the center of the circle straight to the top of the cone. Okay, but don't worry about that. There's no trick problems in there for that one. Okay, so that would be your formula for volume of a cone, area of the base, which is pi r squared, times the height. And we're going to multiply that by 1/3 or just divide by 3 because the cone slants inward to the center. Okay, so that's it for volume formulas. Hopefully this helps you with all of the different volume formulas and makes you understand how they work. All right, guys, good luck.